Today we're going to take a look at how to solve trig equations and just some basic things to look out for when you do these. If you divide by a variable, you actually have, you can divide by solutions or roots. So if you divide both sides here by x, you get x is equal to 1. Alright. The way you want to do this is actually move your values all to the same side and look to factor. So if I subtract x, I get x squared minus x equals 0, and now I can factor an x out. And use your zero product property. If one of these is 0, then the whole thing is 0. So I can set x is equal to 0, and I can take x minus 1 and set it equal to 0 and get x is equal to 1. Alright, so there's actually two solutions here, but we divided one of them out, so we never actually saw that. And that can work in the reverse, too. Suppose I tell you that x is equal to 4. We could square both sides and get x squared is equal to 4 squared. And then we get x squared is equal to 16. Take the square root of both sides, you get x is equal to plus or minus 4. But originally we had just x is equal to 4. When you square or raise both sides to a power, you have the possibility of gaining solutions, and sometimes those solutions won't work. Alright, negative 4 definitely doesn't equal 4, so you got to check for those extraneous solutions, the ones that don't work even though they appear they do. Don't forget your Pythagorean identities. Sine squared plus cosine squared equals 1, and 1 plus tangent squared equals secant squared, 1 plus cotangent squared equals cosecant squared. Your unit circle. And remember, all students take calculus or another stupid trig chart. All trig functions are positive in the first quadrant, only sine in the second quadrant, only tangent in the third, and only cosine in the fourth. Since the trig functions are periodic, they'll repeat over and over again, we can have an infinite number of solutions for these problems. So what we're going to do is we're going to restrict our values from 0 to 2 pi, including 0 and not including 2 pi. And the best way to get good at solving these is to do a whole bunch of them. There's not a rule or pattern to do all of them, so you just have to do a variety of them. So just like when we solve regular equations, we want to isolate cosine x. So we're going to add 1 to both sides and divide by 2. So we have the cosine of x, add 1, and then divide by 2. We get cosine x is equal to 1/2. And remember, cosine is positive in the first and fourth quadrant. So where's cosine 1/2 in the fourth quadrant? Right here at pi over 3. And it also occurs down here at 5 pi over 3. Alright, and you can check these. Set your calculator into radians and take 2 times the cosine of pi over 3 and subtract 1, you should get 0. The same thing with 5 pi over 3. Let's look at number 2 here. We have a cosine in both terms, so if we have something in both terms that's common, we can factor it out. Let's factor out a cosine of theta, and we're left with 2 sine theta plus 1. Alright, and if you're not sure about this, redistribute your cosine back through and you should get back to where you started. Now I have the product of cosine theta and 2 sine theta plus 1 equal to 0. If either one of these is 0, then the whole thing is 0. So we're going to take cosine of theta, set that equal to 0 and solve. And we're going to take 2 sine theta plus 1 equal to 0, and we're going to solve that as well. Alright, now looking at unit circle, where is cosine 0? Where are my x values 0? That occurs at pi over 2 and 3 pi over 2. This is going to take a little more work. We're going to subtract 1 and then divide by 2. So we're going to have sine of theta is equal to negative 1/2. Alright, and where is my sine value negative 1/2? Sine is negative in the third and fourth quadrants, and it's a 1/2 right here and right here. So that's at 7 pi over 6, sorry, and 11 pi over 6. Alright, so we actually have 4 solutions here. Alright, moving down to number 3. This is very similar to the example above. We're going to subtract 1 and then divide by root 3. So I'm going to have tangent of theta is equal to negative 1 over the square root of 3. Now this is a little tricky because tangent is, when you're dealing with root 3's and tangents, that's either at pi over 6's or pi's over 3. And I think the easiest way to figure this out is take, at pi over 6, that ordered pair is root 3 over 2, 1/2. Tangent is y divided by x. So if I take 1/2 divided by root 3 over 2, or multiplied by the reciprocal, I'll get 1 over root 3. Alright, so now, because this is the same thing, pi over 6, as this, we're going to be dealing with the pi over 6's. But where is tangent negative? tangent's negative at the second quadrant and the fourth quadrant. So your pi over 6 equivalent would be 5 pi over 6 and 11 pi over 6. All right. What would happen though if this, suppose this didn't work out to be 1 over root 3 and it was this, then you would know that it would have to be pi over 3 because tangent at pi over 4s is just 1. All right. Number 4. We have the cosecant squared theta equals 1. In order to do these, you can do them two different ways. You're going to have to take the square roots. So suppose we take the square root in the beginning here. I'm going to get the cosecant of theta is equal to plus or minus the square root of 2. All right. It's kind of awkward or uncomfortable working with cosecant, so let's take the reciprocal of this. If we take the reciprocal of the left side, we have to do it to the right side. So we're going to have the reciprocal of cosecant, which is sine, is equal to plus or minus, and this is a root 2 over 1, so I'm going to have 1 over root 2. All right. Now, this needs to be rationalized, the right side here, so we're going to get the sine of theta is equal to plus or minus. We're going to multiply by a root 2 over root 2, and so that's going to be root 2 over 2. All right. And that occurs at, because it's plus or minus, it's going to occur at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right, so we get 4 solutions there. Lastly, we have sine squared equals 3 cosine squared theta. If you want to, there's actually 2 ways you could do this. You could divide both sides by cosine squared theta and rewrite this as tangent squared theta equals 3. What I'm going to do is I'm actually going to replace cosine squared with my Pythagorean identities. If you remember, sine squared x plus cosine squared x equals 1. I can rewrite cosine squared as 1 minus sine squared. So I'm going to rewrite this as sine squared theta is equal to 3 times 1 minus the sine squared theta. And let's distribute that through. So we get sine squared theta is equal to 3 minus 3 sine squared theta. And from here, let's add this to the other side, the negative 3 sine squared theta. So I'm going to add a 3 sine squared theta over to here. And we'll get a 4 sine squared theta is equal to 3. Divide both sides by 4, and we get sine squared theta is equal to 3/4. Take the square root of both sides, so we'll get sine of theta is equal to the square root of 3 over 4 is just the square root of 3 over the square root of 4 is 2. So where is sine a positive? Sorry, don't forget plus or minus. A positive or a negative root 3 over 2. And that's going to occur at pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Alright, and if you have time, go through and check all these. Alright, and they should work.